In this problem, the objective is to implement a recent counter class that tracks and counts the number of requests made within the last 3000 milliseconds for each new request. To solve this problem efficiently, a queue is used to store the timestamps of these requests, which allows us to easily manage and remove outdated requests that no longer fall within the 3000 millisecond window. The recent counter class contains a single private data member, a queue, which holds the timestamps of the requests. This queue doesn't require any special initialization beyond its default setup. The main challenge lies in ensuring that only those requests made within the last 3000 milliseconds from the current request are counted. The algorithm operates as follows. When a new request with timestamp t is made, the first step is to determine the earliest timestamp that should still be considered valid, which is exactly 3000 milliseconds before t. This ensures that only the relevant recent requests are retained in the queue. Any request made before this time is considered outdated and is removed from the queue. This is done through a loop that continuously removes the oldest request from the front of the queue until either the queue is empty or the oldest request is within the valid time range. By removing all the outdated requests, the queue is maintained in such a way that it only contains requests that fall within the last 3000 milliseconds relative to the current request. Once the outdated requests are removed, the current request timestamp t is added to the queue. The size of the queue at this point represents the number of requests that occurred within the valid 3000 millisecond window, and this size is returned as the result. For example, consider a sequence of requests with timestamps 1, 100, 3001, and 3002. Initially, when ping of 1 is called, the queue simply contains 1, and since there are no outdated requests to remove, the function returns 1, indicating that one request falls within the 3000 millisecond window. When ping of 100 is called, the queue becomes 100, and again no requests are outdated, so the function returns 2. When processing ping 3001, the queue is updated to 100 3001, and all requests are still within the valid window, so the function returns 3. Finally, when ping 3002 is called, the queue initially contains 100, 3001, 3002, but since the request at 1 is now outdated, meaning it falls outside the window of 3002 minus 3000 that equals 2 milliseconds, it is removed, resulting in the queue 100, 3001, 3002, and the function returns 3. In summary, the recent counter class offers an efficient method to count the number of requests made within a 3000 millisecond interval using a queue. The ping method effectively manages this by storing timestamps in a chronological order and removing any that are no longer relevant. This approach ensures that only recent requests are counted, making the solution not only simple and intuitive, but also highly effective for real-time applications where it is necessary to monitor and manage incoming requests based on their timeliness. The use of a queue is particularly advantageous here because it allows us to handle the incoming requests in the order they are received, ensuring that the oldest requests are removed first when they become outdated. This first in, first out or FIFO property of queues makes them ideal for this type of problem. The approach is scalable and can handle large volumes of requests over time without becoming inefficient, as only the requests within the relevant time window are retained in memory. Now that the implementation is complete, it's important to test the code across various scenarios to ensure its correctness. Testing should include different request patterns and edge cases, confirming that the recent counter class reliably counts the relevant requests and handles all situations as expected.